This video looks at the domain of a function given in algebraic form. To determine the domain of a function in algebraic form, you want to think about whether there are any restrictions on the input values. We saw in previous videos that the domain is all the possible x values. And so what we're looking for is whether or not we can plug in any x value that we want to. You can start with the assumption that it's all real numbers and then look for any restrictions. For example, if we had y equals 3x squared, what you want to think about is, can you square any number, or are you restricted to only certain numbers that are allowed to be squared? So because we can square any number, that would make our domain all real numbers. We can square any number. In other words, x can be any number. And if x can be any number, then the domain is all real numbers. Now there's a fancy symbol for this. This capital R with a double vertical line on the left stands for all real numbers, the set of all real numbers. But the way we list that in interval notation is from negative infinity to infinity. So the interval notation for all real numbers is parentheses negative infinity, comma, positive infinity. That's how we list the domain if it's all real numbers. For the next one, y equals the square root of 9 minus x, the restriction would be that we cannot take the square root of a negative number. So we call the thing inside the square root the radicand. And the radicand has to be greater than or equal to 0. And when we talk about radicand, we're talking about the expression under the root. Under the root. Now we can't take the square root of a negative, so the radicand has to be greater than or equal to 0. So the radicand in this case, I have square root of 9 minus x. So I'll take 9 minus x. I'll set it to be greater than or equal to 0. And then I have to solve. So if I'm solving, I would subtract 9 from both sides. I would end up with negative x is greater than or equal to negative 9. When I divide an inequality by a negative number, it flips that inequality. And so this would become x is less than or equal to positive 9, because negative 9 divided by negative 1 is positive 9. So that will be my domain, and I just have to list it in interval notation. So I have x is less than or equal to negative 9. So there's no lower bound. I would do negative infinity. Positive 9 gets a bracket because of the equals. So because I had that equals sign, the equal bar, equal gets a bracket instead of a parenthesis. And so I'll have my domain as negative infinity to positive 9.